Hello, I'm Chiu Wu at the University of Tennessee at the United States. The title of my presentation is Using Google's Engine and geemap for Interactive Mapping and Analysis of Large-Scale Geospatial Datasets. The PowerPoints for my presentation can be accessed by scanning the QR code at the lower right corner or visiting the URL at the bottom, gshub.org/IGAC. Here is the outline of my presentation. So first of all, I'm going to talk about the motivation why I developed this package. And then I will show you some information about the package and some tutorials and what kind of key features available in this package. At the end, I'm going to show you some additional resources if you want to learn more about Google's engine or the package. On the right here shows you lane set time-lapse animation from 1984 up to now every year. So basically you can have a lane set animation like for any location around the globe. You can try out the link here. If you click the link on web app or web app 2, you click the link and then you'll be able to actually draw a rectangle around any location and then to create time-lapse like this. If you're interested in looking at the source code, you can click the notebook link upper right corner. So keep in mind, if you use the web app, excuse me, there's no coding, so very easy. This one is built based on the package I developed. So and here I'm going to show you a quick demo, like how the app is looks like. So you can search for any location, and then you can zoom in, you can zoom out. After that, you can click the drawing tool here, draw a rectangle or a polygon or a circle anywhere. Then you can customize, for example, the title, the bank combination. So you can, it depends on the feature you're looking at. You can change different bank combination. You can choose what kind of a month every year you want to look at, change the color. You can also extract, for example, water based on the normalized difference water index or vegetation or anything that can be computed using a normalized difference index, and then you can download those animations to your local computer to show on your website or social media. And as you can see here, it only takes you a couple seconds, maybe 20, 30 seconds. Then you'll be able to get animation like this very easily. Next, I'm going to show you a few striking examples. For example, on the left side is the dying of AOC. On the right here, is mining in Canada. So, for example, coastal expansion in Dubai or river dynamics in South America. And also deforestation in the Amazon. Landslide, you can see here, this is very striking because the landslide lasts for almost a decade. So it's long and large landslide. You can also visualize urban expansion. So this one here in Las Vegas, urban growth and also the water dynamics of the reservoir. Also, for example, urban growth in Dongguan in China. So those are just some examples. You're welcome to explore the app to find any location you're interested in, draw a rectangle, and then you'll be able to create something like this very easily. So those are something that you can do using Google's engine. But before I get into the details about this package, I want to quickly distinguish the Google Earth and Earth engine. So if you are not familiar with Google Earth engine, then you probably are very familiar with Google Earth. So Google Earth is different. They're very different products. Google Earth basically is just for visualizing the imagery. You cannot really do any analysis. So if you're asking some like quantitative question, we all know based on the animation, we know the urban is growing. But if we want to ask like how fast is it growing, like how much urban growth area has been expanded since the past decades, you cannot really know because you can see that it's changing, but you don't know how much. So Earth Engine basically is a computing platform that allows you to do computation based on large-scale geospatial data sets, and it's free. It's provided by Google, free for research, education, and non-profit. Here, I'm going to give you an analogy. So on the left here shows you like image viewer. So if you're using Windows system, you probably are familiar with image viewer. So you can use that to view image, but you cannot do operation. You cannot cut the image, you cannot do mosaicing, you cannot do cloud masking. On the other hand, Google's engine, just like a Photoshop, you can do a lot of complicated operations. You can do some very fancy one, and it's very easy and intuitive to use because you just need to call a few functions. So if you haven't used this before, highly recommend that you try this out. If you want to change your life, make life much easier for you. Again, it's free. You can click the link and go to the upper right corner, sign up using your EDU email address. User is instant approval. So and after that, you'll be able to explore these tabs in here to get to know more how to use Google's engine. And here's one quick application that you can use. Just one line of code, you can create cloud-free imagery. So for this one here, you see a lot of cloud, right? But if you use Google Earth, you probably visualize the imagery. You notice that most images are very nice. They are all cloud-free, but in reality, it's not. So most of the imagery you see on Google Earth actually are processed by Google's engine, are used to reduce cloud. So for example, this is before, and the other one here is after. So you see here like what's the geometric changes before and after. So the idea is very simple. You have a time series of images, for example, every year for every location, and then you have a stack of images. All you need to just maybe choose a percentile, for example, the median value, because cloud usually have high value. So when you change the median for every pixel, and then you get the median, and then you will be able to create a cloud-free imagery like this. Very easy, one line of code. So very powerful. One big advantage of Google's engine is that it has a huge data catalog. So most of the common satellite, for example, Landsat, Sentinel, even a 1 meter resolution net imagery or weather, climate, you name it, all the data sets right now are available within Google's engine. And it has a huge, right now it's over 35 petabytes. So 1 petabyte is 1,000 terabytes. So it's more than 35,000 terabytes. There's no way you can fit this one into a local server, even if you have a powerful server. It's not possible. And it's still growing. Also, if the data set are not available, the one that you want to use are not available in Google's engine, you can upload data set to your account. Each account has 250 gigabytes. So it's a lot of storage that you can upload data if you want to use for your own private data sets. And this is the interface. So you can click here. This one is called JavaScript code editor. So Earth Engine provides two APIs, JavaScript and Python. There's also a recent one called REST API, but that one is more advanced. So most users get started with the JavaScript API. So this is the interface, very simple. You can write the source code here in the center of the code editor. At the bottom here, you can display the data set interactively. On the left side, basically just a folder that you can save scripts. On the right here shows you the results or plotting or kind of a chart or table that you can print out. So you can click the link here. I have a short example, but I'm not going to demonstrate. You can click the link and then to take a look once you have the account approved by Google. And so next I'm going to talk about the Python API, because my package geemap is actually a Python API for geemap. So I want to briefly mention the differences between these two APIs. So JavaScript API, they have a lot of documentation tutorial provided by Google, official documentation. It's easy to get started, and they have a lot of interactive functionality. It's also built in, but the downside is that you cannot install any additional packages. So basically everything you want to do is within this interface. And keep it in mind, is in the browser. You cannot interact with your local computer, okay? So, and everything is constrained within the browser. But if you have data set on computer, you want to transfer back and forth, you cannot. So this is the downside. And in contrast, the Python API relatively has limited documentation tutorial. Most of those are in JavaScript. But if you learn programming, most likely you learn Python as your first language, probably. And also you can easily share scripts, you can do batch processing, and then a lot of options. For example, if you see on the chart in here, a lot of plotting options they can choose. You can also integrate with QGIS, and also a lot of IDE you can choose from. You can use Colab, you can use a Visual Studio Code or Python, and you can also use deep learning. And also you can interact with your local data set. So it's very, very powerful. But I want to show you the key differences, right? You have two APIs, JavaScript and Python. So JavaScript, you can do computation. You can also do interactive mapping. But the Python API only has computation. There's no interactive capability. So there's no way that you can display the result interactively. So all the red crosses in here, loads of things not provided by the Python API. So my goal here is actually to implement this interactive component so they can use this easily, just like what you use the JavaScript API. So how we get the points, right? I'm going to implement this. And so before actually I developed the package, in the past, I also used JavaScript API. So last year, I published a paper in remote sensing environment showing how to use Earth Engine to map wetland inundation dynamics using the 1 meter resolution data and LiDAR data. So here shows you some examples how the landscape is changing, how the wetland inundation area is changing. So for example, from 2009 to 2017, these are all the 1 meter, so very high resolution. And if you see from 2009, it's a relatively dry year, and you see loads of wetlands actually are separated. As time goes on, you can see that it becomes wetter and wetter. So some of those wetlands are actually being connected. So you have a larger wetland complexes. And this is very important because it supports a lot of wildlife and also vegetation communities. We need to find out what's the current status of those wetlands and where they're located, how they're changing, right? So we can use remote sensing actually to support to delineate these inundation areas. So this is a quick result. I'm not going to get into the detail how the algorithm works. You can read the paper, but I want to show you key results. So this is the background, is the 1 meter resolution imagery. The yellow color here is the boundary that we delineated using Google's engine. Keep that in mind, everything is automated. You don't need to download any data. So everything just within the browser. You write the source code, you get the data, you write some algorithm, do the computation, and then extract the result, and then you plot the data interactively. So here shows you a snapshot. And you can see clearly, right, the yellow color perfectly aligned with those wetland areas. On the right here shows you water occurrence. So basically, what does this mean? From the value range from 1 to 6, right? Earlier I showed you 6 time periods. So if there's 1, that means that pixel was only detected as water once. If there's 6, that means within these 6 images, that pixel was always detected as water. If you see from here, you will clearly see that, okay, large water body tend to be more permanent. So, right, if you see from there. So blue column, those are permanent water. And those are from red to green to yellow, those are more like seasonal or temporary water bodies, right? You can see the changes. So this gives you a quick result how the landscape is changing. It's very dynamic. And this is why it's important that we provide an up-to-date status about what is going on the landscape. Compare my result using Google's engine to traditional using, for example, Landsat data. So if you see from the left side here, this is Landsat data from the European Commission and Google using Landsat time series for the past few decades. And so this is for 2015. You will see here, right, the boundary, like zigzag, zigzag. This is a limitation of the 30-meter resolution. Also, if you see the red arrow here pointing to those smaller water bodies, Landsat data was not able to detect these water bodies because most of the wetlands in the region, in the Prairie Pothole region, is relatively small. It's only like median size is 1,600 square meter. So it's less than 2 Landsat pixels. So you will see here more than half of the wetlands are smaller than 2 Landsat pixels. There's no way you can use Landsat to delineate those accurately. Also, we have the national wetlands inventory here on the right here, right? You will see those are polygons. It's very detailed. Those were delineated in the 1980s using manual digitization. It's no longer updated. It's very detailed, but it doesn't reflect the current status of the wetland inundation status, right? And you compare this one here to this one. You see the geometric differences between different products. So clearly, Google's engine can give you a way to quickly delineate the most up-to-date status, and it's free. You just need to write some source code. That's it. And also, I provide the source code and the demo in here. You're welcome to explore the source code and also the demo. You can click, you can zoom in and zoom out and select any locations within my study area to delineate the area. You can also plot all kind of interactive plotting in here. So you can see clearly like how the watershed is changing from like dry year to wet year and then goes back to rapidly dry year again. So very, very powerful. So there's just like a background about what this Google's engine and how you can use Google's engine to do environmental monitoring. This is just for wetland and surface water. You can do anything. You can do urban growth. You can do landslide. You can do natural disaster. You can do temperature. You name it. You just need to somehow transform your algorithm from traditional remote sensing software packages to Google's engine. How to write the algorithm, how to retrieve the data, how to do computation. Okay, so next I'm going to show you, like, after, although I published those paper, it was using JavaScript, but like I said, JavaScript has a limitation. You cannot interact with the local data set. And personally, I could not get used to JavaScript. It's a little bit complicated when you need to design some interactive GUIs. Like, it's not as intuitive as JavaScript, Python API. So next, I'm going to show you the geemap package. So this is it is open source. You can check my GitHub page, and some of the key dependencies in here. You can run in Jupyter. If you know Python, you probably know Jupyter. You can also run it in Google Colab. So support this cloud environment, and you can use pip, conda, or install from GitHub. I also have a tutorial here show you how to install. You can watch my tutorial. And you can easily create interactive maps. You can see from the source code here, just a few lines of code, you can create a map like this, and then you can interact. You can zoom in, you can zoom out, you can search a location, you can load data set very, very easily. So I also provide a lot of examples. If you use Google Colab, you can click the link here on the left side, notebook template. You can also look at my video. So here shows you just a simple code block, how you can get started using the package. You, for example, install the package and then import the library, and then you can create a map. Then you can start loading Earth Engine datasets, right? Here, E represents Earth Engine. It's the Earth Engine Python API. And within the parentheses, this is the unique ID. So think about here, Google's Engine is a huge data catalog. Each image within the catalog has a unique ID, just like each of us, for example, each of us has a social security number. All you need to do is figure out what's the ID, and then is it an image or image collection, or is it a vector or a feature collection? And then you get the data. Then you can start, okay, telling what I want to do with this data set. I'm going to display how I want to how to display the image, right? There are all kinds of ways you can do that. But here shows you a quick example. You can also use Jupyter. Keep in mind, the Colab used the Folium, Jupyter used the IPyLib. So these are two different interactive mapping packages. Personally, I like IPyLib better because that one is like too bi-directional. So if, for example, when user click the map, you want to get the coordinates, you use the coordinate to query the data set. This is something that IPyLib can do, but Folium cannot. The reason why I use Folium is that Google Colab does not support IPyLib. So IPyLib is a lot more advanced, a lot more capability, but Colab currently does not support this one yet. So highly recommend that if you can install the package on your local computer, use IPyLib. A lot more functionality are provided. I also published a short paper describing the package. You're welcome to check out the link. Also, I create a website, so very, very easy to remember, geemap.org. It has completed documentation about the package, tutorial, and how to get started, how to install. I also have all the documentation for every function. So right now has a lot of functions available. The good thing about this is you can see the source code for every function. So if you click a function on the web page, you can look at the source code. And if you're interested in how the package is being developed, how the package was built, you can look at the source code to learn a little bit more if you're interested in learning more. Next, I'm going to show you some tutorials. Right? I have the package, and I create a YouTube channel to share those tutorials, all the video tutorials. So far, I have over 40, so more than 10 hours of length of all the videos. And I have a lot of almost 3,000 subscribers and more than 60,000 views. It's getting quite popular in the Earth Engine community. So you can check out the videos. Here it shows you a list. So far I have, I think 22 or something. The list keep going, so I don't update anymore. Each tutorial I have a full-length video, also a short animation. The full video usually 15-20 minutes. The animation, the GIF is maybe 30, 40 seconds, just give you highlights. I know everyone's busy, so if you don't have time to watch the full video, you can watch the animation to give a sneak peek at what's going on within that video. If you're interested in, and then you can watch the full video. I also provide the notebook. So the notebook is all the source code, so you can reproduce exactly what I did in those video. Highly recommend that if you're interested in the package, check out this video. I want to mention that although the video only like 15, 20 minutes, but some of those video took me many hours or many days actually to develop. The more important is to write the source code to develop those functions, those features to be demonstrated in the video. So the video is short, but it takes much longer actually. So most of these things are actually the new functionality within the package. It's not about the Earth Engine Python API. And so next, I'm going to quickly go through some of the key features, like what you can do using this package. So first, you can do automatic conversion from JavaScript to Python. If you already learn JavaScript, Earth Engine JavaScript, you can easily, if you have a bunch of script on your computer, you can just use a few lines of code to convert automatically all your script to Python. You can also open the notebook and then to convert source code interactively. So all you need to do, go to the Earth Engine website, copy the source code, paste in here, and then run this line of code. It automatically generate the new Python script. So it's very easy if you want to convert from JavaScript to Python. You can also search dataset interactively. So as you can see here, just click on icon and then search any keyword. And then from here, you can see the thumbnail. You can just click the import. It will create a new cell block in the Jupyter notebook and then just execute. So you pretty much, you don't need to write any source code. You can access the Google Earth Engine data catalog, right? As I mentioned, 35 petabyte. Any data set you want, search and then load the data. You don't have to download anything to your computer. So powerful, and it changed my life. I'm not sure if it will change your life or not, but if you get used to it, I'm sure it will save you a lot of time because you don't have to go online to every agency, to USGS, to NASA, European State Agency to download the data set. All you need to do is just write a few lines of code. You can get access to the entire database. You can search the API. So there's thousands of functions within the Earth Engine API. There's no way you can remember everything. So sometimes you just want to search the function, for example, support vector machine, random forest. You want to figure out what kind of a parameter you need to provide. You just need to one line of code and then you can get this one, just like what you did in the Earth Engine JavaScript API. You can also add a base map. So if you use the JavaScript, you are constrained to just the Google Earth map and Google Satellite base map. But in here, there are lots of web services available on the internet. You can easily load those base map into Jupyter notebook, and you have a lot to choose from, right? Tons of base map layers. In that way, you don't have to, again, download the data set. So if you just want to give a quick visualization, this is a way that for you to do that. You can create a split panel map. Right? See from here, just one line of code. When you create a map and then you create a split panel map, you can compare things before and after. So for example, before and after tornadoes, any natural disaster, or anything you want to see before and after. So you can load the layer on the left side, on the right side. This is just a simple example using Google Map and Satellite, but you can use any data layers. You can use the inspector, so interactively to click your mouse and then to query the data set, either it's vector, raster. You can query the pixel value. So similar to the ArcGIS like identifier. You click, you get the information. But keep in mind, this data set is in the cloud. So basically, you click the map, you get the coordinates, and use the coordinate to use the Earth Engine API to query the value, and then return the values back into the client. Basically, in this case here is the Jupyter notebook. So you don't need to do coding. Everything is just click, 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 click. But behind the scene, this is a lot of coding. So for me, I need to actually implement those interface and then query the data set. So save you time. I already do the coding. You don't need to do that. Similarly, you can do interactive plotting. If you're interested in looking at the spectral signature, let's say Landsat data or hyperspectral, all you need to do is just activate the plotting tool and then click your mouse and then you can get the plotting very nice, easily. It can be any data set, any time series. If you're looking, for example, NDVI time series along the years, you just load the data set, click your mouse, and then you get the graph. You can also download it one to your local computer if you want. You can also do time series in Inspector. So they say you're interested in length set time series for specific location. Yeah, I already create those time series for you. All you need to just draw a rectangle or define an AOI. Then you can create a time series for every year. Rather than having to go to the agency to download the data, to filter, and then to mosaic to get data yourself. You can also load the data from your local computer. For example, you have a vector data on your local computer. You want to use this with Google's engine. You can use my package to do that easily. So convert your local object into a server object, and then you can use that to do computation with Earth engine. So keep it in mind. If you're not familiar with cloud computing, data on your local computer, those are not cloud objects. They are not server objects, and they are not parallel to actually to run computation efficiently. So in order to do that, you need to convert your vector data set to basically GeoJSON, and then from GeoJSON to convert to Earth engine object, and then from there you can interact with the object. Similarly, you can use a local data set. So if you are using raster data set on your local computer, you can use the geemap to load the data set, and then you can use that together with Earth engine cloud data set. So you can use that together. JavaScript API code editor does not provide this function. Like I mentioned earlier, everything is restricted in the browser. You cannot do anything with a local computer, but using the JavaScript API, you can. So this is one example how you can do it. Similarly, you can do cloud machine learning, deep learning with Google's engine. So this is one simple example using machine learning and also do accuracy assessment. So most of the things you can traditionally do using decision tree, random forest, support vector machine, or most of the algorithms right now also available in Google's engine. So we can do it easily just within a few lines of code. One thing I want to highlight is that if you use Google's engine, the study area does not really matter. The more important is your research design, your algorithm, because most of data set is at the global scale. So if you figure out what to do with one specific area, you can do it repeatedly for any other location. If your study area is not really unique, so you can do that for large scale studies. You can do 3D terrain visualization, just like this one here. You can use terrain, and then you can load the dataset from Google's engine, and you can visualize in 3D. You can also publish the app. So traditionally, if you are writing journal articles, once you publish the paper, you might have some data set stored on your local computer. Sometimes people might have to ask you for access. But if you use Google's engine, you can easily create interactive maps or apps, and then you can share the link within your paper. People can go to the app and then to interact with your data set interactively. So this is a nice way that things get still be interactive rather than static, or sometimes might be after a couple of years, you might not be able to find it anymore. So very easy. You can publish the app and then you can share the link with anyone, or you can embed into social media, and then it's still interactive. So people look at your Twitter, they will still be able to zoom in and zoom out on the app. So very, very nice. Highly recommend. Also, if you want to create some interactive web apps, just like the one I show you at the beginning of my presentation, right? Click the web app and then you can draw a rectangle and then you create the animations. So those are also things you can do with using the geemap package. Very easy. So once you create the Jupyter notebook, then you can use the Voila. It's another open source package to turn your Jupyter notebook into a standalone web application. Then you can deploy this one using your local computer, or you can deploy it to a server. And then you want to have an URL and then send to anyone. People want to go to the URL and then can interact. They don't have to know the source code behind the thing. And they can just interact, zoom in and zoom out, draw a rectangle, click some buttons. So this is a quick way that if you want to disseminate your result to the general public, you can usually use this to create some apps. And this is another app that you can use to create a time-lapse animation. but you can also do computation. So for example, if you're interested in surface water dynamics, you might be wondering, for example, it's changing, but is it growing or is it shrinking? What kind of a dynamic? So you can quickly use the app in here to get the statistical result, how the area is changing. Is it water dynamic? It can be urban growth. It can be vegetation dynamic. It can pretty much anything that you want to investigate. And as you can see from here, there's no source code. Everything is interactive. You choose some button, and then you can also download the statistical results to your computer. Very easy to do. And I think this will be the last animation that I'm going to show you. So this is a surface water app for the entire US. So I load, for example, every county, if you're interested in a certain county, how the water is changing. But keep in mind, this is not perfect, but just show you some idea, the demo. And all you need to do is just select a county and then adjust some parameters, and then use the normalized difference water index to extract water for 37 years, since 1984 all the way to 2020. Right, you can see the change of the water is in this county specifically is going down. You can click and save the results to your local computer. Again, no coding, but you're welcome to look at the source code behind how this app was developed using the geemap package and also the Python API. Everything you can customize, so you can change the GUI, you can change anything. In addition to using the existing data set, you can also just simply draw an area of interest, right? Draw a rectangle. You can compute for any location, so it's not restricted to the US only. You can do it for any other countries or location, right? Select rectangle, change the bank combination, and then you get the results. It only takes you a couple of seconds, maybe up to 1 minute. So very, very easy to do. Try it out and see if you like it. And so lastly, here are some additional resources if you want to explore a little bit more. You're welcome to check out my GitHub repo to submit official requests, or you have any question with the package. I also have the other repo, 360 Python notebook examples. If you already learned JavaScript, you want to transition from Python, you can go to my repo. So I converted all the JavaScript example from the Earth Engine documentation to Python. So you can see the table content in here. You can correspond to the Earth Engine official documentation. If you click and then you look at the source code, excuse me, open the Jupyter notebook, and then you can click here to run this one in Google Colab. So once you have the account, you actually don't have to install anything on your local computer. You just go to my repo, click the icon, and then from here, you just click. You'll be able to execute the source code and then to display the data set interactively. You can also join the Slack channel. So I create a Slack channel for geemap. Right now, I think it's close to 500 people. So a lot of people in there asking questions. And if you want to interact with me or other geemap users, you're also welcome to check out my YouTube channel. You can watch the video. You can leave comments if you have any. So usually I'll look at every comment and then respond if needed. Okay, so thank you for your attention. That's all for my presentation. I'm happy to answer any questions you might have. Thank you.